Welcome back to the Greater Essex County District School Board calendar, where we are exploring the fundamentals of mathematics. Each month, we're diving into a big idea from the Ministry of Education's Focusing on the Fundamentals of Math, a Teacher's Guide, and in particular, the table summarizing curriculum expectations from our current Ontario mathematics curriculum that always has been and always will be fundamental for developing students' understanding and proficiency in mathematics. In this video, we'll wrap up our exploration of the development of mental math skills in order to work towards mastering math facts. In this video, we're going to explore what is easily the most challenging elementary operation of all, division. Recall from our video Unpacking Multiplication, we unpacked this operation as the idea of iterating equal groups or quantities. So in this case, iterating equal groups of 4 3 times, which students can access through counting and repeated addition. Well, what about when we're given the total number of donuts and we want to determine how many each of, say, 4 people are to receive? Well, we can access it the same way we do with our very young learners, and we use this idea of fair sharing to try to split up these donuts in a equal and fair manner. In this particular case, we had 12 donuts. We had divided them amongst 4 people, and the result is 3 donuts per person. This is actually called partitive division because division 2 has different structures for it. So now let's think about a scenario where we don't know the number of people. And what we do know is how many donuts we want each person to receive. So in this particular case, instead of 12 donuts divided by an unknown number of people, what we can actually do is take 12 donuts and divide by 2 donuts per person, the rate of how many donuts there are per group or per person. And what we'll do is something a little different. It's not quite like fair sharing that we saw in the previous scenario. We actually tend to use this idea of repeated subtraction. So we actually create groups of 2. I grab 2 donuts and I place them over here. I grab 2 more donuts, I place them over here. I repeatedly do this, and then I count up how many groups I have. Here I can see that I will be able to give 6 people 2 donuts each. This is the second type of division called quotative division. All right, are you ready to look at it another way? Let's pull up some squares on the screen here, and you'll notice that I'm giving them to you in groups of 3. There's 4 groups of 3 here, so there's 12 squares. The question I have for you, I'm going to cover them up, and then I'm going to throw some cups behind there, and I'm going to ask you how many are under each cup, if we know that each cup is hiding the same quantity of squares. Well, if we have a look, you probably guessed it's 6. And actually, it wasn't a guess. You knew that if it was an equal number, I had to divide it into 2 groups. But now let's think of what type of division this really is. Since I was taking 12 squares, and let's go ahead and line them up, and I was partitioning them into 2 groups, I know that there were 6 in each of these groups. Because I had 2 parts, we call this partitive division. I knew the number of parts, and the result was how many per part, or what we call a rate, partitive division. If I look at this algebraically, we can see that there were 12 squares, and that's equivalent to 2 times the quantity in each cup. We could say Q represents the quota, or the quantity of squares per part. And when we go ahead and partition this, we're actually using partitive division, so we're dividing by 2 in order to reveal the rate, which is 6 per part, or 6 per cup. All right, let's go ahead and let's look at the other type of division. So If we get that off the screen, now let's look at another scenario. Here it is. I'm going to give you 18 squares. We have 6 groups of 3 here, which is 18 squares. And I want to know if we want 6 squares per part. That's the rate. How many per part, or how many parts will there be? Well, if we think about this, what we're actually going to do is we're going to essentially use repeated subtraction. We're going to create these groups of 6 by pulling 6 away from the group, and we will see that we get a whole 3 parts. Again, this is quotative division because we know the quota per part. So division, just like addition and subtraction, has different structures that we should be aware of and that students need to be aware of because every context is asking us to divide in different ways. All right, let's go ahead and let's actually see what this looks like algebraically as well. Here we had 18 squares and we knew that we had 6 per cup. So now you'll notice our variable represents the number of parts. It's not how many are in each part, it's the number of parts. And we're going to divide by 6 because we're going to repeatedly subtract 6 from the group. And we end up with a total of P equals 3. All right, let's look at something just a little bit more complex, just to show how important partitive and quotative division really is when things get a little more complex. I'm going to go ahead and tell you that there are 23 squares total here. The squares that are under each cup are equal. So we know each cup has an equal number of squares, and we have 5 squares left over here. When we add up all those squares, we know the result is 23 squares. So how can we figure out how many squares are under each cup? Well, I'm sure many of you probably thought that if there's 23 squares total, if I remove those 5 additional squares, we'll be left with 18. And those 18 are divided amongst the cups, giving us 6 in total. So you would be correct, and that would be an amazing strategy. But let's look at what this actually looks like mathematically. If I line up my 23 squares and we follow that idea that, you know what, there's going to be 3 groups and we had 5 left over here, we could use a mathematical model. This is like a linear model we have here, and we can actually go ahead and label it like a number line. So if we had 23 squares total, and I know that my parts begin before those last 5 squares, we could actually go ahead and try to determine that there are 18 squares in total in those cups by removing those 5 from 23 or moving back on the number line. And now we need to reveal how many are in each part. Well, in this particular case, since we have 3 parts, this is partitive division, and we can see that actually each part will have 6 in them. Mathematically or algebraically, we can look at this as the equation where C represents the number of squares per cup, or the rate, and we can write it as 3C, or 3 times C, plus 5, is equal to 23. And let's think about what we did here. We removed 5 from 23. Well, if I do that from one side to keep things balanced, I'm going to do it from the other. And we see that 3C is equal to 18. And through partitive division, we could divide by our 3 parts and reveal that we have 6 in each cup. In this video, we've unpacked and just scratched the surface on the importance of division and the 2 types of division, partitive and quotative division. We hope that you've been enjoying our Fundamentals of Math series from the Greater Essex County District School Board calendar. We'll see you next month.